When we receive our training, we would practice printing and cutting the individual chromosomes out and arranging them following the appropriate pattern. It means a lot to me that I can do this practice with my daughter and that I can share with her that every individuals are different and this is determined by our DNA. I'm a geneticist and I work on patients with rare genetic diseases. My focus is diagnosing these conditions and developing a therapy for these patients. I'm a translational researcher, which means that I do both clinical care and research development. Genomic medicine refers to using a patient's DNA information to guide clinical care.
It allows you to make a diagnosis you couldn't make otherwise, to identify a treatment you might not be able to recommend without that kind of information.
Example diseases include cystic fibrosis, Down syndrome, Huntington diseases. We are working on these very translational concepts that can have immediate impact. It's estimated that over 300 million people are affected with these conditions. Using the most advanced technology, whole genome sequencing, we can diagnose about 50% of the patients.
For many of these families, their search for answers is long and filled with uncertainty.
When you go into the hospital and you have a condition that you have no idea what to do about it, it can feel very hopeless.
These searches for an answer would go on not years, but decades.
Now we are able to deliver very rapid answer to the patients regarding their diagnosis. This can be as short as 5 to 7 days.
By utilizing new genetic technologies, we can provide those answers faster and change the patients' lives.
Being able to put a name on their conditions or the symptoms that they're facing is life-changing.
Our diagnostic lab is the sequencing core for the Undiagnosed Diseases Network, the consortium that NIH assembles with experts in clinicians and researchers all over the country to solve the most challenging undiagnosed genetic disorders. NIH is also supporting us to launch transcriptome sequencing. When we do DNA sequencing, we are getting the patient's genetic code. Then when we are doing transcriptome RNA sequencing, this is evaluating the downstream effect of those genetic code.
It means a much more expansive analysis of the genome to get as much information you can obtain that can help for the diagnosis and treatment.
Rare diseases are really the poster child for individualized medicine. Eventually, personalized treatment is the goal.
I think it's pretty apparent immediately how much he cares about not just the research, but the people he mentors.
He guides us well, provides great instructions and direction.
I am so honored to be working with my team. I learn from them every day, and it's really an amazing environment. For every family with a genetic condition, I think they deserve to know the answer. Behind every mutation, there is a person. Every diagnosis carries the story of their lives. These diagnoses, I see them as hope.